Hi everyone. So the question we are taking up here is we have to check if a linked list is palindrome. What's a palindromic linked list? It basically means that if we, compare the first element with the last element and so on and so forth, then, or let's say we can also say this as if a list reads the same forward and same backward, it's a palindrome. But what's the thing here in linked list is that it's a singly linked list. If it were an array, we would simply use a two-pointer technique. We would start our left with 0 index and right with the last index. And then move inwards and check if every element is equal. But here in linked list, the problem is that we have only forward nodes. And that is where the trick of this question lies. So what kind of, let's say we have a palindromic linked list, let's say. So there can be two cases. Which two cases am I talking about? I'm talking about my length of my linked list could be either odd or even, correct? So, um, if I have this linked list with odd length, and let's say I want to get the middle node. So, what happens? We can use a two-pointer, tortoise in here technique. We could start our slow and fast with 1, and then my slow would point to 2 and my fast would point to 3. And then my slow would point to 3 and my fast would point to 5. So, what does it mean? When my fast dot next is null, then my slow is the mid, correct? Let's say for even length, what happens? Let's say I have 1, 2, 3, 4. So I start my slow and fast with 1. Then I move slow to 2 and fast to 3. Now my slow moves to 4 and my fast moves to null. Correct? So when my fast is null, then where is my slow? It is pointing to, it was pointing to 3, right? So, sorry, wait. Initially my start and fast is slow and fast is pointing here. Then my fast moves by 2 steps. So fast is at 3 and slow is at 2. Now my fast will move by 2 steps and it will be null. And what will my slow move? It will move by 1 step. So it will reach 3. So my slow is pointing to the first node in second half of the list. Right? So, since we can move only forward in our linked list, so what happens is that if let's say we reverse the linked list, if we reverse the second part of the linked list, what happens is that we would somewhat get something like 4, 5 here and 4 there, correct? Now we can see if uh now what happens is we get this, or let's say uh if let's say we reverse it from 5 itself, let's say 5, then 4, then 3. Does it matter? No, not really. So we have to reverse the linked list from slow pointer. What will happen then is then we'll again start checking for every node in my first and second half of the linked list. If they match, they are palindrome. If not, it is not a palindrome. So this is the logic that we are using right here. So for this, firstly, I'll require 2 pointers, slow and fast. So my slow initially points to head and my fast points to head. Now what happens while what's my stopping condition? While fast is not equal to null and fast dot next is not null. What happens? I'm going to move slow by 1 step and fast by 2 steps. So what happens now? We are going to reach slow, right? Now what we do is we get slow is equal to reverse list. Let's reverse the list from slow up until the end. So we reverse this. And now what we do is we again start our fast, or let's say list node current is equal to first is equal to, and here list node second. We can also do this. We can rename variables meaningfully. It will point to head. Now, while my so how am I going to check? So this is a condition that will be that so the condition here will be until my second is not equal to null. That means we have not reached the end of the list on the second half. Then we see if my first dot val is not equal to second dot val. It means we found a mismatch, correct? And then here we immediately return false. Else what we do? We and after coming out of the loop, we return true since we processed all the nodes and there was no violation found. Else we move our first and second pointer by a step. So now what we do is we implement this function, reverse list. So this will go like private list node and reverse list. So here we'll have list node head. So how do we reverse a list? Iteratively. We'll need to have 2 pointers, which will be list node previous, initialized to null, and current, initialized to the head of the linked list. And in the end, we're going to return previous, correct? What do we do is, while my current is not null, it means we have nodes left to process. So what we'll do is, first step is bookmark the remaining list. So this next node is equal to current.next. So we've bookmarked. Now what we do is we flip the direction. How do we flip? So we say current.next has to go to previous. So this is how we do it. And now we're going to move previous and current by a step. So previous equal to current and current is equal to current.next. So this is how we do it. And yeah, so let's run this code. 1221, it's returning false when it should have returned true. Okay. Sorry. My current will not be current.next. It will be next node, right? You remember we bookmarked it. So yeah, now we submit it and yeah, this was it. So thanks for watching. Bye.